Okay, do a quick thing. Sure. Okay, can you hear me now?
Yes. We can hear you and see you.
Wonderful. Okay, let me share my screen. And can you see my screen now?
Yep. All good. And just once you start and run the PowerPoint, it'll fill the screen better, so it'll be bigger. So once you start.
Okay. All right.
Run slideshow.
All right. Okay.
All good.
All right. So I'll go ahead and start now.
Yep. Let's start. It's 11:02, a little bit late, but this is what's new in replication.
Wonderful.
Srinivasan will start and go.
All right. So thank you so much, everyone, for joining. Good morning, good afternoon, and good evening. And my name is Srinivasan R Mottupalli. I work in HCL as an enterprise architect. I've been, like many of you, I've been breathing informatics for the last 2 decades, actually. So, I have worked in various other components, SQL being my primary role in most of my career in informatics. So, replication is the new one which I'm venturing right now. Okay, with that. Let me start my presentation. I'll try to. Okay, I don't know how to get rid of my video.
If it doesn't cause problems, you can leave it on. If people out there get glitches in the audio or in the video, I'll let you know.
All right.
It's working fine now. If anybody else has an issue, throw it up in the chat, and I'll try to address it.
Okay. All right. So the topic that I'm going to talk about is what is new in replication. Basically, we will see what are new with respect to 1410 overall, right from 1410 XE1 to up till now XE6. And here is a disclaimer, just gives me comfort to use some superlatives. And so let's see the agenda here. The agenda is we will start with some performance aspects of it, and then we'll move on to the HDR non-blocking checkpoint. Some of the sharding extensions that we have added, we'll look at it, and some more on the smart trigger. Again, that's an extension to the already existing smart trigger feature. We have a post commit trigger, some few additions, and then some of the new options that we have introduced in CDR utility. If time permits, actually, we'll also see some of the other improvements that we have done. We have, I have around 50 slides, and you may see that I'm in some of the slides I'm rushing through. So that's in the interest of time, actually. So anytime during this session, please feel free to post your question in the chat window. All right, let's get started with some exciting one in ER performance. It's not as simple as it looks, but the majority or quite significant amount of work happened in the ER performance, end-to-end in ER performance. So with respect to replication throughput and to reduce the latency. What you will see from the from as a user, you will see that you'll start using the SMX transport mechanism for ER. There will be some multiple network pipes. We'll use the corresponding on-config parameter for this, and then we will also see that some of the smaller transactions being spooled into in-row headers. So here is a slide which gives some numbers, some test scenarios which we have internally tested, and we got these numbers. So, I mean, it depends on various things, but I just wanted to share this to say that the data load had demonstrated around 15x improvement. The OLTP aspect of it, with some light DML activities. Earlier, it was just 500 transactions per second to be, all the replication pushed to other peers, but now it has improved up to 2,000 transactions per second, which is, tremendous. The resync was showing up to 2x resync. What I mean is the target has the data. This is the normal customer scenario where he has the data and we do the sync. Normal sync, without any data on it, it showed around 4%, up to 4% improvement. ER performance, just to exploit this or leverage this ER performance related changes, these are the recommended parameters that you would like to set. You see that in 1410XE6 onwards, ER uses a SMX connection. So we are actually going to see some of the configuration related to SMX. We need some adjustments to it. Most important thing is this QMEM. Earlier it was recommended to be 128 MB, and now we want to just bump it up. Eval threads 0 and 7 in total evaluation threads we want to see. The Q header, let's see, hold it for a minute, and this SMX num pipes, this should be 2 or higher. This I'll skip. And SMX compress, earlier when we were not using SMX connection for communication, we have used CDR NIF compress, and now we would like you to use SMX compress for the network compression, and also encrypt underscore SMX for encryption, network encryption instead of encrypt underscore CDR. Now going back to this QHDR DB space, we whatever was earlier configured, we need more than that, because now we have added a new column with 30,000 bytes, LVARCHAR, to store the intro queue headers if the transaction size is less than 26 kilobytes. So hence we need more here. Then this is the most important slide to basically when you upgrade from previous versions into XE6, we want you to put, force all the changes into the disk, make sure that everything is flushed to the disk. How do we do that? In the previous version, you have to make sure that the ER queues are empty. I'll tell you in a minute why this is most important. Replay position and current log position are same. We need to make sure this also. The respective commands are given here. You can just use these commands to make sure the queues are empty and replay position and current log positions are same. After doing this in the previous version, you have to stop the ER using CDR stop. And after upgrading to a new version, which is XE6 and in future later version, the reason why we want to make sure these are empty is because we are mandating the ER to start with a clean start. So this clean start is going to drop these tables and then recreate it. Why we need to do that? Because we have added a new column into these 3 tables, and then which is like 30,000 bytes here. This explains why we are having a threshold of 26 kilobytes for a transaction size. So any transaction less than 26 kilobytes will be now stored in this, instead of there's another column, pre-existing column called CT buff data, which is a smart block. All right. So let's get into the non-blocking checkpoint in HDR. This non-blocking checkpoint is already present in RSS, but we are extending that to HDR here. Checkpoint occurring in the primary, HDR always blocking it. That's the main problem we faced. Okay, so during this blocking time, it also doesn't allow us to modify the buffers. So that's why we want to address this. And also the log replay performance on the secondary is at risk, right? So it's going to take longer until the buffers are flushed. So just to give a recap on how the transactions and the role of checkpoint here, to explain what is non-blocking checkpoint role is. Basically, any DML operations, when you perform, what we actually do is that we try to see if that buffer is existing in the buffer pool. Otherwise, it has to be read in. And then, we just store that buffer into the physical log intact without any modification. We also store a logical log operation corresponds to whatever operation it is. In this case, it's a delete. So we are going to store a logical log operations on this, and then we go and make the modifications into the buffer pool, into the buffer, the corresponding buffer. So once we do this for multiple transactions, multiple pages, the whole LRU will look a lot more dirtier. Basically, the buffers are actually, there are a lot more dirty buffers in this. So when the checkpoint interval happens, what we need to do is to take all those dirty buffers and then flush it into the respective DB space. That's how the checkpoint really works. Now, where the non-blocking checkpoint fits in this scenario. When we are doing this, when we are doing the checkpoint, what we are doing is we need to flush all those buffers, and then we need to apply the logs received from the primary. When it is blocking, it is possible that some of the logs which are already pushed to the secondary are all in this in the staging files, and then all these things have to happen. And during the flush, we don't do this log applying the logs, and that's going to even adding fuel on the fire. So what this enhancement is going to do is to now perform these two operations in parallel. The benefits that we are going to get is that log replay performance at HDR is going to be much, much better, and the data is much, much closer to the primary data, because this is most important in the high availability and disaster recovery. It's also that the improved response time for the user applications, be it on the primary itself. So how do we do? There is a new configuration parameter, secondary and a sec underscore non-blocking underscore checkpoint, which mimics like RSS underscore non-blocking underscore checkpoint. That's the existing one. So now this new onconfig is going to be available for both HDR and RSS. Both can in both the types of servers, this will be honored. Okay, so what happens when primary does blocking checkpoint? HDR will also go for a blocking checkpoint. But when primary does a blocking checkpoint, RSS actually was doing the non-blocking checkpoint, and it's going to continue doing the same. This is the subtle difference between the non-blocking checkpoint of RSS and HDR. When primary does non-blocking checkpoint, on the other hand, the HDR and RSS would go for non-blocking checkpoint. So this is where we get the benefit. All right. So how do we enable it? This we have seen. It's just to enable by saying one. But if you are already if you are trying to move into XC6, we recommend to use this instead of even RSS non-blocking checkpoint, even though you are using RSS, because this particular on config is going to be deprecated in future releases. Here is a snapshot of what is happening, and I just wanted to highlight how the secondary HDR and RSS behaves when there is a blocking and non-blocking checkpoint. When primary goes for a blocking checkpoint, the blocking checkpoint is indicated by little asterisk here. So this star indicates that this is a blocking checkpoint, and this LSN is on the HDR also went by the blocking checkpoint. Whereas if you look at the RSS, it was a non-blocking checkpoint here. And when primary does a non-blocking checkpoint here, the secondary, the HDR is also going for non-blocking checkpoint, and RSS as usual, it's going to be a non-blocking checkpoint. So this is a difference, between the HDR non-blocking and the RSS non-blocking. Okay. Let's now see some of the additions to the sharding aspects of it. So sharding is
Srinivasan?
Yes, sir.
I have a question. I have a question in the chat that I thought I'd let you break here and answer this question about a address a node that has Informix 11 and a node with 1410 FC6 using the new SMX protocol is address how to communicate between the two nodes when they're on different versions. Is there any complication? I don't know if you can see the chat. That's basically what the chat question says from Frank Thomas.
So here, okay.
Can you see the chat?
Yes, now I can see the chat, and
I was trying not to interrupt you. I didn't want to let you get too far. So.
All right. So can this wait until the end of this, so that we just
Sure.
Right. So
whatever is your preference.
Wonderful.
So we'll wait to the end, guys. So just put your questions in there, and we'll let Srinivasan read them at the end.
Yeah.
Still keep putting the questions in if you have some. Okay.
Yeah. Thank you so much.
Yep.
All right. So with respect to sharding, we'll go into the sharded table joins. So sharding is not new to Informix as such, but what is new here is the joins using multiple sharded table. So, okay. So what is the problem statement? The problem statement is, if in a query, if I use a multiple sharded table, today, or pre XC6, or even before that, pre 1410, it was actually throwing an error like this: not more than one sharded table is allowed in a query. But now, the question here is, if the shard is fully compliant shard, I'll tell you what the fully compliant shard means. If it's fully compliant shard, why can't we allow it? That's what we are going to try addressing this with an example. Here is an example which is actually demonstrating what the problem is. So in this thing, I'm using two shards. One is defined on T1, and the other one is defined on T2. But in this, the expression is different. In the shard expression, as you look at it, this takes C1 between 1 and 3, all the values of C1 between 1 and 5 on table T2. That's how this is defined. And if I see how the table distribution looks like, I have two instances, and these are the two instances we have created a shard on. And this is a node 1, this is node 2. Now you see that, as you all know, that the sharding is nothing but this table is as if, it's on the single server, just that distributed across multiple instances. So if I give this kind of a join here, what actually should happen in a normal case when all the rows are in a single instance is that I need to get all these rows, including the value, including the row with a C1 being 5. Right, so that's how, all these three joined with this, and then the 5 and 6 should also be joined. But because of this distribution, what happened is, this sharding, I mean, if I allow it to go, this would yield me 3 rows from the instance 1, and then only 1 row from instance 2, which is matching with 6, because it does a local join here. Okay, because unfortunately the expression is different here, and the value 5 of T2 is actually residing in the first instance, and this is not going to be joined at all. All right, so in these kind of scenarios, we clearly see that we cannot allow multiple shorted table in general, and this was the main reason why we were actually not opening it up. So now what we are trying to do in this success case is that we are having the short table. Similar shards are created on T1 and T2, but here in this case the expressions are pretty much exactly the same, in fact, right? So what do we do? How the data is distributed now, it's different, right? 1 2 3 1 2 3 here, and then 4 5 6 and 4 5 6 8. So now, since it's going to do the local join, I'll qualify the first 3 rows from the first instance, and then 5 and 6 from the second instance, and now I get the right output. So these are the kind of shards that I say is the fully qualified shards, right? So there are few more conditions here. This is a simple flow chart that actually says that, okay, if T1 and T2 are shorted table, if it's not shorted table, we don't care. But if it's a shorted table, we want to perform few validations and then go ahead. And if the validations are really true, then we want to do some deep validations and then allow it to go for a shorted join. If this is not possible for some reason, we also have a fallback mechanism. We'll see that in a moment. What are the validations that we are performing? Here are the mandatory conditions through which it has to go, each and every shard. I'll see. As you can see, the short table must have a joining column as a key. Here key is C1, and here the joining column is also C1. And this short is also the joining column is C1. So this is mandatory, and we also see that the strategy should be same. Here in this case, expression, it can also be a hash or C hash, consistent hash. It should also have the partitions, to be exactly the same. Partition condition should be exactly the same. And, in case of non-expression, this is an expression format. In case of non-expression, for example, C hash or hashing kind of a strategy, then only the equi-joins are allowed. That's a common limitation on the hashing. And then no cross products between the short tables. These are the validations that we are performing in order to let it go on, let it actually execute the short joins. So now here is an example which quickly we'll just skim through this. The conditions are same, and for performing any sharded queries, we need this use underscore sharding on. So when you do that now, it's able to get the data. Note also that it's also allowing some other expressions like in clause and the normal expressions, because we are doing some deep validations here. So in case of no fallback, for some reason, especially here, as you notice it, the UTM group 2, the instance is having a different values compared to different expression compared to the second shot. So these two are not compatible. And in that case, if you execute it, it's going to throw an error. But we want to actually give some sort of a fallback mechanism, although it is going to be a little bit, or I would say even more suboptimal plan, but we just wanted to just run it through the completion. So we have introduced a new environment called short join underscore fallback on. So by doing this, earlier it was throwing an error because we did not actually give that environment, but now it's going to perform this. How does it perform? We are utilizing, two things here. One is, actually, you see that the query is rewritten. The original query, what we have given here is rewritten to use the common table expressions here to actually execute it. And by doing that, it's going to create a remote path and then make a temporary table out of it. And then with that, it's going to join with this table. As I said, it's suboptimal. Normally sharding is done when the table is really huge and we actually want to distribute that across multiple instances. This is just a way to get around that problem, and the query is getting executed to the completion. Now, the next aspect on the sharding is the sharded query. So the sharded query, enhancements that we have done here. One enhancement is that we have there's some cases where we need not mandate the ER on the edge nodes. So edge node is created when you want to use some informational shots. I hope you can go through that with the documents, or you are already aware of these things. Informational shot is nothing but if you have an edge node, you can define the edge nodes like this, and then if there is an informational shard, what actually is done is that you independently load the data on each instance, and then the table, the same table name, its schema, everything is same, but you are independently loading the data, and it is not maintained by the actual shard procedures, but but the table is logically connected to all of them. So in those kind of cases, I can enable this to be an edge node being one, so that this actually need not have a ER. So this is the new addition that we have seen. And here, if you look at it, it is having only the server ID as one. So although I have 3 servers here, those are all not defined here. And if I define it, then I will have a ER, but you won't see any CDR threads on IDS2 and IDS3 because those are not defined at all here. So if I have an example here where when I have inserted a data, one row in IDS1, one row in IDS2, and then IDS3. And if I use the sharding here, and based on the informational no ER sharding, it's going to pull in all the data from all the shards, right? I mean, all the instances. This underscore no ER is new to 1410. And this is another, okay. Sorry. I don't know how to get rid of this on the top, but anyway, so I see that this particular, I've taken the same example here, and for some reason, if IDS3 is going down, the problem with those kind of scenarios is that in the normal scenario, you see that use sharding is on, and you're trying to do a select star from T1. And because the coordinating server, which is IDS1, is unable to make a contact with the IDS3, it's going to fail with sharding internal error. So to get around this problem, we have something called survive node failures. How do we survive these kind of node failures? Especially for sharding, this is crucial. We have an environment called grid node underscore skip on. If you do that, Now, when you do select star from T1, although there are few rows from IDS3 are still missing here, but still it executes this, all the rows. It executes this query successfully and get at least whatever instances which are up and running, it's going to get those rows. But along with this particular thing, we also provided some two utility functions to see that how many nodes were skipped. So this is most important because, even if you normally by default, if you're setting this grid node skip on, it's going to, it may bring in all the data. Even the IDS3 is up and running, it may bring in all the data, but you're not sure whether the rows are coming from all the instances or not, right? So to make sure that your application should take care of checking this and then do the necessary action. Okay, let's get into the smart trigger. This is another new addition to the smart trigger is the session survival. Okay, so a simple recap on smart trigger. This is also known as push data events. Actually, part of this, I'm not going to cover the entire thing, but just to give a brief intro for people who are just seeing this now. So what actually smart trigger does is that it can be invoked from the clients, and then if there are any changes in the table, you can get a notification to the clients. So that's what we want to do instead of polling the server all the time. So we actually provided this triggers. Okay, so, and the best part is, it's also going to give the output in a JSON format. So you can, whenever there is a change happen in the table, you can get those notifications, based on some where clause, some subset of data that you can just, keep a watch on. The use case for this is generally, if there are some specific tables which are very sensitive tables, and when it is touched by any DML operation, you want to actually get some events and do some necessary action, or you are monitoring, send those data into some monitoring thing, some tables or things like that for audit purpose or anything of that sort. All right. So this is actually set up using our admin APIs. We'll see those admin APIs, how we are using it. JDBC and ODBC have their own wrapper functions, APIs, like IFX Smart Trigger and stuff like that. So those are much more, easier to use on these applications. Okay, and we'll also see that, how this is comparable with CDC APIs. So a quick recap again on the smart trigger. When the DML operations happens, IDS sees that, and this is the filter which our ER is taking care of, and it filters out those records which are qualifying for the smart trigger API. All the rows are sent to smart trigger API, and it is up to this Java application which reads these JSON stream and then do the necessary action, whether it has to distribute the data into other repositories or do, send it to other messaging system. So that's about Smart Trigger. Now we are coming into the crux of what we have done over Smart Trigger, the session survival. These Smart Trigger APIs, which are already there, you see that, we are using the admin API like task of push data open. It gives a session ID. You register with some, the JSON document. Here is a document which actually sends the query and what is the database owner and table. And whenever there is something happening in the table, which is, and this query is actually matching certain rows, then your client is going to be notified. This is the exact same way even CDC works. Both are external to the database. Both are invoked from the client, and as you can compare this, here also there is a session, and here also there is a session, and both this session ID is used in the IFX hello read, which is a large object read that we do on the session, right? So both are doing exactly the same thing. These are the things which are already available. What is new is the restartable aspect of it. We have introduced a new push data set detach new commands in the admin API. Once you do this, after doing the registration, you do this, you will get some unique session ID. And this unique session ID is important for you to join back even if you bounce the server. So earlier, when you bounce the server or when clients disconnect, you're going to lose the context. Whereas now, after push data set detach, giving you unique session ID, the session is survived and it's going to be remembered by the server. So now it also came up with one more thing, which is the reset capture. This is another cool extension to smart triggers, where you can reset capture from a specific log ID and log position. All right. So by this, you can even just go back in a few logs, and then you can start capturing it when you rejoin into the sessions. So now that we are not taking care of these events automatically, so we need the push data delete option. Here you can supply a session ID, the unique session ID to delete it, or you can delete all of them. So what is that we don't have earlier was that, when without this survival, when the client disconnects, we lose all the context. But now we can detach it, we can rejoin it, recapture, and we can delete when we don't want it anymore. Let's get into post commit trigger here. The new addition is a little minor, but just again, some context here. Yesterday, Andreas talked a lot about this asynchronous post commit triggers. And it's called in multiple ways: async trigger, replication to SPL, or other ways to call. Even there's one more thing like ER to UDR, right? So all means the same, which is post commit triggers. Replication to SPL is what we are doing, and it's enabling us to apply the changes dealt via stored procedure on the target side. Instead of directly writing the changes into the target table, we are now going to invoke a stored procedure on the target side. This gives some lot of flexibility to say that it doesn't enforce any key to be having. You don't have to have the primary key or unique key or internal ER key and so on. So these SPL routines, basically, whatever the SPL names that we are talking about here, those routines can be either SPL or CUDRs. And this is the example. Again, I'm just going to go a little fast here because this was already covered yesterday in a different session by Andreas. What we have added here is that now on the SPL name, you will see that there are two new data being added, which is user ID and session ID. This is for some audit purpose. Basically, when you are inserting a value like this, eventually on the target side, it's going to invoke this SPL. And by invoking it, what exactly we are doing, this SPL is on the target side. By doing it, what exactly we are doing is that we are inserting the data into the staging table, along with the user ID and session ID. And this way we know for sure that this transaction was modified by which user ID has, created this transaction, which actually, initiated this transaction, basically this insert, which particular user ID has initiated this, and which session ID. Similarly, yes, sir.
This is your 10-minute warning.
All right, thanks.
The yellow flag, whatever it is.
Okay, so and similar things. So this 10 minutes, beyond that, I have question and answers, right?
Well, to a point, the next session has to start at the top of the hour. So,
okay, all right.
Plan
okay,
accordingly.
all right. Fine. So again, this one was about JSON SPL name, and which is going to have a similar output in the JSON format. Now let's get into the CDR options, the new options, which is migrate server and check catalog. The migrate server is a very handy utility to automate your data migration to a new server using a ER environment. So CDR migrate server, it has a very simple interface to give a source and target. Obviously, both of these things, instances, are actually defined in the SQL host, and we can also use some phase and other options here. So basically what it means is that here, if you look at this example, CDR migrate server, I have instance 1 and instance 2, and I'm using a phase being all. All the phase basically means that it will define the server, it will define all the necessary replicates to replicate all the database objects from this instance, CDR group 1 instance, to the group 2 instance. So that's what it does. But without this exec option, it is going to be a print only. So you can see that how our CDR migrate server is generating the CDR commands to accomplish the whole migration. If you're happy with all the steps that are generated in the print only, you can go ahead and execute with the exec, so that it will actually shoot all the commands internally. You can also have other phases. There are many other phases, up to 7 phases. I have truncated here, but the one of the phases is just define the ER. If you are just want to play around with the CDR just to define some ER and things like that, you can very well use these things to play around. The CDR check catalog, this again is a new utility to perform a consistency check. What it means is that here again the interface is much simpler. It says CDR check catalog, and I give my master server as some server whose metadata is intact, basically, which I believe in, that there is no issue with that. So having given that instance name here as a master and check for all of them, so what it does is it verifies the metadata, it verifies all the metadata between all the other instances in the ER domain, right? So that's what it's going to check for, whether the server metadata is inconsistent and replicates are consistent across all the servers, all the replicates and replicate sets. So all these things are checked internally. It's a simple FSCK kind of tool to verify that everything is okay. We have other improvements that are there. The other improvements are like onstat-g LAQ. This is extended with current LSN and lost LSN being printed now. The most important one I want to highlight here in the interest of time is that these last two things. So LAQ, if you are running this on the secondary server, this is run on RSS. So if you are running it on secondary server with a repeat mode, it is going to show this where the transaction latency is 0 records, so 0 seconds. Basically, what it means is your primary and RSS are pretty much caught up. and then the way apply rates that at which it is running this. So it gives a little bit of progress how it's doing. Uh, the other feature extension that we did is in the temp tab no log with a new mode called 2. So this is the actual problem here is that when today on the primary server, we always set it to 0 or 1, but on the secondary server, we always set it to 1 because it has to be all the logical logging on the temporary table must be disabled. That's how it's always 1 on secondary. But what happens when the failover occurs? When secondary becomes a primary, and when secondary was holding the value of 1 and primary needs a value of 0 to enable all the logging on the temporary table, we are, the DBA has to make sure that he goes and resets this value. So now with this mode 2, what happens is based on whether it is primary. If it's a primary, the log will be automatically enabled. If it's a secondary, then the log will be disabled. This is a handy one. This is another case. The use case is that the customer was having some scripting error where he mentioned that his master his receive only participant was used as a master node. So by doing that, there were a lot of unintentional data loss. The reason is with primary participant, if you're trying to, match with receive only participant, there's a possibility that you can lose the data. So here, what we have added is we are going to bail out in these cases. And when the master, when it is defined as a receive only, and if that is used as a master, it's going to bail out. But this is going to bail out only for check repair or sync option. If you are using a check only option, then CDR check only is still allowed. Here you see the extra 2 rows here. If I don't have this option, I would have lost this data. All right, so now flow control delay statistics on RSS and SDS. Currently, the issue is, we don't have any visibility about, why the RSS or SDS are kind of delayed in terms of, the log applies, why it is lagging behind. So this is a brief, recap on what is flow control. If you're not already aware, flow control basically primary server actually limits a log activity. It's going to hold back some of the logs without sending it to RSS if you set these kind of on-config parameters on the primary side. Now what we have added is that on the primary side, we have added these 2 parameters so that this parameter says that, how many times the primary has held back not sending or rather, how many times it has delayed sending it to the secondary servers, right? So that's going to give some inputs as to why, the RSS server or SDS server is not catching up. The other addition is that the temp DB spaces during secondary recovery. The problem actually is that for some reason the temp DB spaces are down on the secondary. The only option we had is primary must recreate, so that the secondary will automatically be got the same data. But this is otherwise there's no other option directly fixing it in the secondary. Now it will be automatically reinitialized when you restart the secondary server. ER sensitive and insensitive databases, ER the replicates can be created on all these different kinds of database. Pre-XE6, it's going to throw these errors to say that this is not case sensitive, or this is case, it's not case insensitive, and so on, right? So this particular issue is now resolved to operate with multiple kind of databases. With that, actually, I conclude this session, and these are the various references you have. You can go and read about it for your own education. Now I'll open it up for any questions. Actually, now let me go through the chat window here.
And you can see it okay?
Sorry?
You can see the chat fine?
I can see that, yes.
Okay.
I can see that, and I see, okay, there's only, okay. So in the ER, if I have node with Informix 11, using the old protocol and node with, excellent question. Actually, this is one of the reasons where if you have mix of this kind of servers, then you will have to use that the corresponding CDR protocol that we have used before. So this is good. It's going to continue working that way, right? So the next question I see. Oh, okay. Vladimir already answered this. To prevent blocking checkpoint on HDR server, we can use the log staging dir directory with Informix 12. Okay, then log data is staged in the directory. Or okay, so this is another interesting question. Actually, as you see that HDR sometimes can go for blocking if primary is going for blocking. So log staging directory still makes sense. And earlier, see now what we are trying to improve upon is that now HDR can apply the logs as well in parallel. So we would have progressed from the secondary point of view, from the HDR point of view, we would have progressed applying those logs much ahead compared to what we used to do, having a log staging dir. But still, the log staging dir parameters still valid for HDR. I hope that answered your question. Can we have different locales on different servers in ER? Absolutely. Yes. In fact, this is the one we took care of it, and the case sensitive and insensitive, we did not take care of it. So I think, that this particular sensitive and insensitive database mix was a last piece of puzzle. I think, we have taken care of that. So I think that's all the questions I can see. Any other questions before we let you go?
Oh, I don't see anybody typing, but that's fine.
Excellent.
Great presentation, Srinivasan. I think everyone enjoyed it. People kept joining. The number kept going up. And no one left. No one left early. But you now only have a 5-minute break till the next one starts. So
wonderful. So thank you so much for joining this call, and have a wonderful sessions ahead. Thank you.
Thanks, y'all.